In the same way that we've now been able to miniaturize components for computer chips, there's a group of us at Cornell that has figured out how to make those computer chips independent. I want you to think about the penny. And it turns out that on the penny, there are two Lincolns. One is on the front. The other one is actually located right inside the Lincoln Memorial, which is on the back of the penny. And if we zoom up to that second Lincoln, that's the device that we're talking about here. This little thing can measure voltages and then report back to the outside world what those voltages are. So in essence, it's a tiny computer. And what our group has been trying to figure out how to do is to put legs on these computers and allow them to walk. In essence, making a robot out of a computer chip that is only a few fractions of a hair diameter. Imagine, for example, a surgical arena where a patient is lying on an operating table and a surgeon has reached a region that is too difficult to operate on. Maybe a tumor is attached to a very sensitive part of the brain or something of that sort. Instead of reaching for the scalpel, the surgeon reaches for a syringe and injects thousands of these tiny little robots. These robots then sense the kinds of chemicals that are being exuded by the tumor. They move towards the tumor. They shrink wrap around the tumor and encapsulate the tumor by forming a polymeric shell, and then that stops the growth in its tracks. That's the dream anyway. What's amazing is that, well, this is a fantastic vision. Every one of those individual steps can be engineered today. These computers are really the product of interdisciplinary interactions between groups in physics and electrical engineering. We're essentially adopting a paradigm of origami, and that paradigm is very useful because all of the manufacturing technology for computer chips is two-dimensional. So what we do is we fabricate the computer chips in 2D, and then within a couple of additional lithography layers, we can put the legs or the swimming appendages on. We then release the object, it folds itself up into 3D, and then swims or walks away. The fact that we have in-house technology that allows us to build these microscale robots basically puts us ahead of the field. And so the ability to manufacture things on campus in the nanofabrication facility is what's allowed us to really take this leadership position in this area.